Hey, so I hope you guys are doing good. This self-isolation is really difficult, but hopefully we just get through this within a few coming weeks and things will return to normal. Just stay safe. I really, really, really miss you guys and I wish I could see you. Um, but yeah, I'll get to see you guys very soon anyway, so I'm just being optimistic. So we actually looking at chapter 15 today. And so far our whole aim in this book has been to provide an economic framework towards issues involving the environment. We also examine key principles of designing effective environmental policy. With chapter 15, we'll do things slightly different and lean towards what is more pragmatic, sort of real world policy analysis. We turn towards an examination of actual environmental policies in the United States. So chapter 15 has to do with what environmental policies regarding especially air pollution has been enacted in the United States and whether they've been effective or not. Um, so it has a lot to do with law and a lot of history. So majority of the things I'll probably say you can actually read it on your own, but I thought maybe this lecture and slides will actually be helpful and be more succinct in terms of your study. Okay. So specifically in this chapter, we examine federal policy on air pollution in the United States. Right. So I'll start with an introduction of air pollution, but to actually understand air pollution, and you probably know this, you've probably seen this at some point in your life, or definitions you've already seen these at some point in your life. We basically do not see it, but we know it's all around us. And I'm talking about air, right? So in fact, there's without air, there's no possibility of survival. As it was well said in your textbook, for human beings and other living organisms, the air is to us what water is to fish, right? We actually need the air to survive. Our very existence basically depends on it. Okay, so parts of the Earth, right? The surface air, which we already know, is known as the troposphere. Okay, so that contains about 78% nitrogen, 21% oxygen. It contains a mixture of other gases and some amount of water vapor. Amidst all these is other gases or things put there through human nature as well. So that is what we call the surface air or the troposphere. Okay, so this is not a science class. I won't delve into it too much. And then we have the stratosphere, and this is the upper layer. And this is basically made up of trace gases such as ozone, right, which blocks out 99% of harmful ultraviolet rays and prevents things like skin cancer, which is really harmful. Okay. Right. At the same time, it traps heat reflected from the Earth's surface and keeps our Earth pretty much warm. And does make the Earth more hospitable for organisms, which is really awesome. Okay. So, hey, happy face out there. Right. Okay. But in the last 40 to 50 years, the severity of air pollution, particularly climate change, has become more acute and in fact worrying, and this is largely due to the fact of humans. As humans, we've contributed to this. Um, for the last 50, even probably more than 50 years, really. Um, and there's a plethora of air pollutants, right? So I did talk about the last 4 decades, the severity of air pollution become more acute. We do see it in our statistics. We do see it especially in climate change, right? And there's a whole plethora of air pollutants. We have nitrogen, carbon dioxide, we have carbon monoxide, we have radioactivity, we have dioxins, we have sulfur, right? A majority of these pollutants are generated by humans through production processes and in some cases consumption processes as well. Okay. Well, the disadvantage of these air pollutants is they have potential health damages, and I think that's the first aspect or the first worrying thing, right? So potential health damages such as lung cancer, asthma, bronchitis, right? Things that can actually deteriorate our health and lead to, in some cases, mortality, right? It can also affect plants. Okay, so these health damages are not actually related to just humans, but animals as well. But generally, it can affect living organisms such as plants as well. Okay, so in the destruction of crop yield, and also it can lead to damages to materials. Okay, such as surface erosion, right, or deterioration of buildings. Okay, so we do know that we have a high amount of air pollution and it's largely caused by humans, and this is some of the negative effects of air pollution, right? So damage to health, damage to plants, and basically damage even to non-living organisms like materials or buildings. Majority of this air pollution actually, or the majority of the air pollution the Earth is facing right now is due to continuous emissions, and we did talk about continuous emissions. If you remember from I think chapter 2 or chapter 3, right? So, for example, sulfur dioxide from power plants. Okay, so sulfur dioxide from power plants is always going to be produced so long as the power plants generally are running, or emissions from automobiles are always going to produce so long as cars are actually running, or automobiles are running, right? Hence the word continuous emissions, right? And in the United States, particularly, we've known that we actually have an issue or a problem with air pollution. Okay, so expenditures on air pollution in the United States have increased dramatically since the 1970s, right? And since the 1970s, there's actually been a calculated measure, a more calculated measure to curb air pollution. And this calculated measures we actually see later on has been largely through policies and laws that have been enacted to actually try and control for the pollution. Okay, so the main question, right, that you should probably be thinking about as you're actually reading through your textbook, or you're actually listening to my voice, or looking at this lecture is, has it been effective? Okay, so there's been a mass expenditure or mass spending on trying to curb air pollution in the United States. There's also been policies that have been put in place to reduce air pollution. There's also been laws that have been put in place to reduce air pollution, but have they been really been effective? And I think that's a really good question to actually take a look at. We still know that we have the problem of climate change and global warming, but are these policies and laws actually doing anything really? And I went to the EPA website and actually have this really cool graph where you can actually see air pollutants or national air pollutant concentration averages from 1990 to 2016, and it doesn't really take a genius to actually see that yes, these policies in a way have been effective. There's been a decline in almost all national air pollutants. Um, in some cases, the decline has been faster for some pollutants compared to other pollutants, but generally, you are seeing that negative decline, which is pretty interesting, right? So all emissions have declined over time. I think what is interesting is that carbon monoxide emissions have declined by 85% since 1990, which I think is really cool. Okay, lead, for example. So where is lead? Okay, right here has declined by 81%. Okay, sulfur dioxide has declined by 80%, and nitrogen, I think that's nitrogen dioxide, has also declined on average of 80% as well. Okay, so there is evidence of decline, right? However, emission data like this does not paint the whole picture, and that's something we need to be considering, right? So we actually need to do a with or without analysis, and hopefully from your last exam and studying for the last exam, right, you remember the with or without analysis, essentially what emissions would have been if the policies were not pursued, and that would sort of give us the whole picture of whether our laws and our policies have actually in fact reduce emissions. Okay, so your textbook actually has this really cool data, and I was trying to find it online, but I couldn't really get it, so I just had to steal it from your textbook. Okay, so we look at volatile organic compounds, we look at nitrogen oxides, we have all these pollutants, carbon monoxide, sulfur dioxide, particulate matter, right, in different forms, and ammonia. Okay, we look at it from 1990. Okay, and when we say CAA, basically we're talking about the Clean Air Act. Okay, so the Clean Air Act is a major law that was passed to actually curb air pollution. Okay, so in 1990 to 2020 or 2020, which is basically now, right? If the CAA or the Clean Air Act wasn't passed, okay, how are things going to look like? Okay, so this is going to be the amount in 2020 of volatile organic compounds in the atmosphere, nitrogen oxides in the atmosphere. If the CAA wasn't passed, carbon monoxide in the atmosphere is going to increase by, that is not really much if you think about it. Sulfur dioxide increases as well, particulate matter, both forms, or both concentrations actually increase as well, and ammonia increases. Okay, so without this Clean Air Act, right, without a law to try and curb air pollution, we do see that there's an increase in emissions. Okay, but with the CAA, we actually find drastic reductions. Okay, so we have with the CAA, basically volatile organic compounds will be 13,704, nitrogen oxides will be 10,000 92, carbon monoxide 84,000, and so forth. Okay, so we do see reductions in terms of actually without the CAA and with the CAA, right? We can actually find a difference, and we see a reduction in most cases, right? Although the reduction for ammonia is pretty small. Okay, so emissions with the law are I think the statistics prove that they are lower with the exception of maybe a few of them. Ammonia is not really too low per se. But in a way we can conclude that the policies have been effective in reducing emissions. Okay. So we'll probably do a little bit of time travel. Yay, a lot of time travel. Okay. Right, and we'll look at air pollution control laws, right? So we'll look at a brief sketch of that. Okay, so prior to the 1960s, there was no federal regulation concerning air pollution. It was largely regarded as the local concern to be dealt with under local nuisance law. Okay, so when we say local nuisance law or nuisance law, essentially, right, it tends to be fines on property owners for activities on their property is considered to be a nuisance. So for example, you burn in something and it causes a whole lot of smoke, right? You actually get punished for that. And that's an example of violating a local nuisance law. Okay, and air pollution was sort of mitigated or controlled in that sense, right? In 1963, the Clean Air Act was established, and it gave federal grants to states to develop state and local air pollution control programs. Okay, and at the same time around 1963, federal research on air pollution was also extended, which is good. In 1967, we had the Air Quality Act, which is the AQA, right? And in 1967, generally, criteria for ambient air quality was set for 6 common air pollutants. Okay, so we had criteria pollutants, right? So we targeted 6 common air pollutants. So we found it was sulfur dioxide. So that's, I think, CO2. Forgot my chemistry. Then nitrogen oxide. So that's NOx. X could be any number, right? Ozone. We also have particulate matter, which is basically PM, carbon monoxide, and then lead, which is LB. Okay, so those were the 6 air pollutants that was actually sort of targeted in 1967. And then moving forward, so this is just a brief sort of like timeline. You can actually go in your textbook, has more details. Moving forward, we had the Clean Air Act amendments of 1970. And this gave federal control in terms of air pollution matters. Okay, so there's a uniform national ambient air quality standards, which were looked at, and a variety of technology-based emission standards were introduced, right? And there were also stricter standards for automobiles, which were introduced around that time. And then we had the CAA amendments of 1977. So when we say CAA, basically is the Clean Air Act. Okay, so just to let you know. Oops. Let me write it here. Okay, so you have the Clean Act, just to make things a bit more clear. Okay, so we had the CAA amendments of 1977, right? And this brought about the PSD, which is also known as the Prevention of Significant Deterioration Areas. Okay. And essentially, these are areas already cleaner than the national standards. Okay. And also had the non-attainment areas, which were created. Okay, so it actually led to creation of the PSD areas and also the non-attainment areas. And these areas did not meet the national standards. Okay, and there was some sort of controversy with this because well, they actually found that areas with better air quality than the national standard had an unfair advantage in terms of new industrial development. So most people or most companies wanted to sort of invest or live at areas where air quality was generally better. Okay, but eventually the government or the federal government will correct this. Okay, and then we have the CE amendments of 1990. Okay, so under the CE amendments of 1990, new car emission standards were introduced. For example, new technologies such as fume catching nozzles, clean cars were also introduced, and they actually introduced 5 main sections. So they have the motor vehicles and fuels. Okay, so this is in addition to those pollutants I actually talked about, right? Those criteria pollutants we did talk about. Okay, so 5 main sections. They have the motor vehicles and fuels, acid rain, a section on air toxics, stratospheric ozone problems, and then finally a section on urban air quality, right? And these were just to target or set emission standards for all these areas. Okay, to basically sort of improve air quality eventually. And 189 toxic materials that were to be controlled were also listed under the CE amendments of 1990. Okay, right, so that's sort of like a brief timeline or a brief history. Okay, the next thing we'll look at is national ambient air quality standards. And basically the government or the federal government has basically set 2 levels of standards to be established by the CEA, and that's the primary and the secondary standards. Okay, so the primary standards is defined, right, as to be set at whatever level is required to protect the public health. Okay, so this word is really key. Okay, so the public health. But what do they mean by the public health? Well, the public health basically means, sorry about that, the public health basically is related to children, those with breathing problems. So for those example, those who have actually respiratory problems or things like asthma, and the elderly. Okay, and then they have the secondary standards, which is supposed to be set at the level necessary to protect the public welfare. Okay, so hence that's the difference between the primary standard and the secondary standard. Okay, so the primary standard, we have public health, has to do with children, those with breathing problems, and then finally the elderly. Public welfare has to do with damage to crops, okay, animals, and buildings. So basically you're just looking at more of the economic welfare, okay, with the secondary standards. Right, so next thing we'll look at is stationary source control. So stationary source control is basically emissions from a stationary point, right? So what about stationary sources of emissions in the United States? How are they basically controlled for? Right, so in 1972, the EPA were given the authority to establish emission standards that will basically specify the technologies that polluters will have to install and operate to reduce emissions. Okay, so we have these technology-based effluent standards. Okay, the EPA was given this power in 1972. All right, so what the EPA basically did was it identified acceptable technologies that basically reduce pollution. And in a way, they provided incentives. Remember, economics is all about incentives, right? Or policies is all about incentives. They provided incentives for firms to adopt these technologies. Okay, so that happened beginning of 1972, right? But I think one interesting question is the cost effectiveness of the technology-based effluent standards. And they actually found that, a research was done later on, and they found that actual programs of the TBES, which is basically a technology-based effluent standards, were 4 to 6 times more costly. And in a way, firms were actually reluctant to sort of hop onto it. At the same time, it actually led to higher margin abatement costs, which in a way led to smaller improvements in ambient quality. Okay, so the higher margin abatement costs a firm faces, the more reluctant it is to actually clean the environment. Okay, because it's actually costly to clean the environment to some degree. Okay, so that's sort of like one disadvantage of the technology-based effluent standards. Another form of stationary source control is emission trading. And emission trading basically consists of two parts. You sort of know of emission trading. We did talk about it in class. Okay, so the first part is basically putting a limit or cap on pollutants. Okay, so firms basically have a limit, right, on how much pollutants they can actually spew into the environment, right? And the second one basically sort of looks at this market-based system, right? So you have tradable allowances equal to the limits that authorize allowance holders to emit a specific quantity of the pollutant, right? So polluters, so essentially polluters basically are supposed to hold permits in a certain amount equal to the emissions they actually produce, okay? And those who are willing to actually increase pollution must buy permits from those who are willing to actually sell those permits, right? So in a way, that's how the emission trading essentially works. Okay, and the most famous form of emission trading has to do with the cap and trade, right? So the cap and trade system have been used to address one of the nation's most significant air pollution problems, right? So for example, we had a reclaim in 1993, and it basically applied to sulfur dioxide and nitrogen oxide emissions. That's 2003, so that's 10 years later. The total nitrogen oxide and sulfur oxides were reduced by 71% and 60% respectively in Southern California. So obviously that did work. Okay, you also have a cap for mercury. Okay, and the cap was put in place to reduce mercury emissions. Okay, so majority of firms in the United States actually emit mercury into the atmosphere. And a cap was placed to actually reduce those emissions as well. And then a cap was placed for sulfur dioxide emissions as well. And we already saw in the previous graph that sulfur dioxide emissions have reduced roughly by 80% ever since the cap was placed. Okay, right, so we have our blue line, which is basically sulfur dioxide emissions. Right. So in a nutshell, what we can say is that there is evidence that policies in the United States have been effective in actually trying to control emissions in the United States, essentially. Even if we're looking at stationary source emissions, which are easier to control, I think, to some extent. The next time we'll take a look at mobile source emissions and what policies have actually taken place in the United States to actually control for those. I'll suggest you read your test book, okay? This is chapter, I didn't want to spend too much time on it. To be honest, I think it's pretty straightforward and has to do with a lot of laws and policies. So it's something you can actually read through and sort of understand. It's nothing esoteric. There's no economic concepts that need to be studied. Actually, there's zero math in it. Okay, so something you can just read through. It's more of law and history and understand. But again, if you don't understand anything or if you're unclear about anything, please don't hesitate to send me an email. Don't hesitate to ask me questions. And I really miss you guys. Love you. And I will probably hear from you soon. Okay, take care. Bye.